So where you would start? From the center of your circle, we're assuming this is a half circle here. You want up to that point of tangency making a right angle, right? We know this is a right angle, just intersection of horizontal and vertical. We need to know this angle. To find it out, we're going to use this angle, which is going to be made up of two angles, a right angle and then this one. And yes, you hit it on the head. That angle is found by doing the inverse tangent of 2/12, or slope. Which is 9.46 degrees. Which makes this whole angle 99.46 degrees, which makes this angle okay, 80.54. Because that has to add up to 360. It's a four-sided figure. Then I'll give you some hints. That's a huge hint. Go from there. So, what'd you get for this little distance right here? 2.46 there, okay? How about this height here? Perfect. That makes this height here 4.79. What'd you get for this length here? 28.74. So now for our areas, we have rectangle here, 28.74 by 10. So 287.4. That's square feet, but I don't have room for the units right now. We have this triangle, 4 points. What's that? The tangent of the 9.46 equals 4.79 over, call that x or whatever. Yeah, that would work too. Subtracting 10 from the 14.79. So we got 4.79 times 28.74 divided by 2, which gives us what? $68.323. We'll go 3.2. Let's just go 3. Then we got triangle 3 here, which is 2.46 by 14.79 divided by 2, which is going to give us what? The way smaller than that. Um, 18.2, we're going to call it. And then over here, this angle is 279.46 degrees, correct? No. 99.46. You subtract from 180. I subtracted from 360 the first time. It's 180 across here. You subtract the 80.54. So piece 4 there is pi times 15 squared times 99.46 over 360. We still have to use 360 for the full circle. So pi times 15 squared times 99.46 divided by 360. 195.2. So to get our area, we add those all up. It's going to give us what? 569.1 square feet is our area. What do you think? Not so bad? Glad to hear you say that. Okay, so what we want to look at now, gentlemen, what happens if it is not a half circle? Actually, Jasper's got a great idea there. No, make it into a full half circle. Let's say that this is 60 feet wide and only 20 feet high. So obviously not a half circle. We're going to give this over here. Let's make it a 10-foot wall. We're going to give this a 412 slope. We cannot work with this. The way this is, the only way to solve this would be to use calculus. We don't want to use calculus. So how would we possibly find the result? Well, what we would do is we would extend this down to make it so that this part here is a full half circle. So our first step is to find the radius or the diameter of that full half circle. So from this center, we would extend straight up. We know this piece here is 20 feet, right? What's this piece here? 30 and 30. And technically, we're extending all the way down here, and this is going to be X all the way down, right? So we know that 30 times 30 equals 20 times X. Look familiar? That's that arch formula. 30 times 30 equals 20 times X. So what's that come out to be? It does come out to be 45 for X, which means our diameter is 65, which means our radius is 32.5 feet. So what does that mean to us? Well, first of all, I'm going to get rid of all this crap. What it means to us is that what we have to add on down here to get from 20 to 32.5, I have to add 12.5 feet. Does that make sense? So that means now this height is 22.5 feet. From here out hasn't changed, has it? That's whatever it was up here from here out. This, of course, now is 32.5. So now we're going to treat this just like we did before. I'm going to get rid of this. We're going to draw our center, our radius up there to get that a right angle. This is a right angle. Now what? Inverse tangent of 412 is 18.43 degrees, correct? You sure? What Ryan did was this. He did inverse tangent of 4 divided by 12. That's why you've got to make sure you use your parentheses in there. So that is 18.43 degrees. So that makes this 108.43, which makes this angle here 71.57, right? Sure, right? And now it's just like what we did before. The problem is once we're done, once we find the area of this, we've got to subtract out this extra piece down here. This one down here, that was the 60 feet line. How do we find this area to subtract out? Well, we would have this rectangle here, which is 12.5 times whatever this distance comes out to be. Here, we have a triangle that's a right triangle. This is 12.5 and this is 30. We would find that angle, wouldn't we? Of course, the triangle itself is just 30 times 12.5 divided by 2 to get its area. But we need that angle. That angle would be the inverse tangent of 12.5 divided by 30. So 22.62 degrees, which makes this angle 22.62 degrees. And this is really the angle we needed because that's now a sector of a circle that's 22.62 degrees. So that's how much we need to subtract out. You subtract this piece out, you subtract this triangle and this, and that's it. That's the whole area that you have to subtract out. What little one? That's part of this big rectangle here. But let's add a little bit. So, I mean, that's not so terrible, right? It's pretty terrible. I'm hurt. No, just kidding. I'm going to make you guys try this. Oh, we'll still call that 412. 80 feet. Yes, I am. So, go to it. Obviously, your first step is to find the radius. So for the radius, you've got the 40 times 40 equals 20 times x. Gives you the 80 equals x. So the diameter equals 100. So the radius equals 50, right? So what that means is we are now adding 30 feet onto this. So from the center of this up to there is 50 feet. Right angle and right angle. This is still the 108.43, correct? This angle down here then is 71.57, right? So that angle, as we said, was 71.57 degrees. So you are going to chop this down here and across here. So I'm going to let you guys go from there. Okay, so what'd you guys get for this length right down here? How about 15.81, we'll call it. You're a little off on that? Let's try it. That would be just cosine, so it'd be 50 times the cosine, 71.57. Yep, 15.81 works. How about for the other side over here? 47.43, you say? Sounds about right. Yes, 47.44. 47.44 is all the way up here, all the way to the top. So that makes this piece here 9.44. And this piece here, 28.33, that sounds right. If I can get my pen to work, maybe. So then from there, it's just a matter of finding the areas. You've got area 1 here, which is 28.33 times 38. Then you've got area 2 up here, which is 28.33 times 9.44 divided by 2. Area 3 here, which is 15.81 times 47.44 divided by 2. And finally, this over here, that angle is 108.43 degrees. So that area would be pi times 50 squared. Pi times 50 squared times 108.43 over 360. What'd you guys get for a total area there? Haven't got that far yet? This right here. I'm going to subtract this out later as part of a bigger piece. You could have just done it times 8, then you'd only have to subtract this part over here out. Yeah, you'll get the same spot. I'm doing the whole thing right now just because it's going to tie into what we do next. So let's see here. We got 28.33 times I'm doing these two areas all together. So 1210.3 we're going to call this. 15.81 times 47.44 divided by 2. 375 even. And then 3.14. I don't know why I put 3.15 there, but times 50 squared times 108.43 divided by 360. 2364.4. So we add that all up, we've got 7. These two I combined. So we've got 9, 8, 14. So 3,949.7 square feet is the total of the whole thing. Now what do we have to subtract out? Well, we're going to subtract out 30 by whatever that came out to be. Well, that was 15.81 plus 28.33, which is 44.14 by 30. So 44. So 1324.2. We have this triangle over here. This was 40 by 30 divided by 2. That'll be 600 square feet. But we need this angle up here. The only reason we need this angle up here, come on. The only reason we need this angle up here is because it's the same as this angle, because these are parallel lines. So that angle is the inverse tangent of 30 over 40. $36.87 is correct. So then we need to subtract out that area of that sector, which will be pi times 50 squared times 36.87 over 360. Give us 804, we're going to call it. So 2728.2, so we subtract that. We're at 1,221.5 square feet is the area of what we had there. So 1,225 square feet up there. What do you think? Not terrible? What if this here wasn't a tangent? That if this here slope isn't tangent to that roof. In other words, what I mean is this. Let's say that this here, let's make this 40 feet. Let's make this 16 feet. Now this time I have to give you this amount. This here is, oh, let's make it 10 feet. 8-foot height. Let's bring that in a 212 slope. So you can see this is not a tangent here. So when we go from the center up to that point, and we are still going to have to go from the center up to that point, it doesn't form a right angle. That complicates things considerably. That's what we're going to spend our time working on Thursday. Oh, this one's so much fun for me, though. To be honest, it's just an exercise in finding triangles and applying the laws of sines, cosines, and basic trig. On the engineering side of it, you would use this. If you're on the architectural design side of it, you would use this. At the level you're training for right now, you would not. If you take the next couple of steps up, like working the lumber yard, doing the plan drawing and stuff like that and estimating, then you would use this more. So I will concede to you at the level you guys are training for at the construction site, you're not going